Okay, what I propose to talk about right now is inequalities. This is the greater than, less than, or equal. This is greater than, less than type material. So you handle these, and please bear with me. I'm filming this with a allergy problem. It's changing from winter to spring here, and I always get sick around that time. So I will be coughing. My voice will be different, and I may be moving a little bit more slowly. So anyway, what we would do is subtract the 2. You get 3x equals 12, and you do the same thing over here. You get 3x is greater than 12. Greater than. So then we would divide off the 3. We get x equals 4. Over here, we would divide off the 3, but because we are multiplying or dividing, the inequality could be changing. Okay? What you would do is switch the inequality direction. So I divide off the 3 and we get x and 4. I did divide, but it was by a positive number. So the amount faced towards the x will continue to face the x. That's different from here. Where I will subtract the 2, we have negative 3x is greater than 12. I would divide off the negative 3 and x, and I get negative 4. Now, because I divided by a negative number, I switch the inequality direction. The amount faced towards the x now faces away from the x. Okay? This inequality means two things at the same time. It means that x is greater than 4. It also means that 4 is less than x. This means x is less than negative 4. It also means negative 4 is greater than x. This means or equal to. So that is 2x minus 1 is greater than or equal to negative 11. So I add my 1. I get 2x is less than or equal to negative 10. I divide off that 2. Because I'm dividing, I drop the inequality sign. I get x. I get negative 5. Now I did multiply or divide, but it was by a positive number. So the amount faced away from the x, it continues to face away from the x. So x is less than or equal to negative 5. Or negative 5 is greater than or equal to x. It means the same thing at the same time. So subtract 5. Negative 4x is greater than or equal to 8. Divide off the negative 4. We get x and negative 2. Now because I divided by a negative, the inequality direction does change. Okay? Okay. With example 3, we have 7x plus 9 is greater than 3x minus 13. I would subtract my 3x, and we have 4x plus 9 is greater than negative 13. Subtract your 9, and now we have 4x is greater than negative 22. Divide off your 4. And x is greater than negative 11 halves when you reduce. Okay? Example 4, 23 is less than or equal to 3 times x plus 7 minus 4. Once again, we would distribute the 3 through, and we'd have 23, because we always handle these exactly like equations, except for that exception right there. We get 3x plus 21 minus 4, which combines to 17. Subtract the 17. We get 6 is less than or equal to 3x. Divide off the 3. And we get 2 is less than or equal to x. It's customary to write variables on the left, so we're going to do a little bit of a switch here. I'm going to move the x over here. I'm going to put the 2 over here, and the mouth must chase the larger meal, so we will follow the x when we move. This is not changing the inequality direction, because the mouth faced away from the face towards the x, it continued to face towards the x. It faced towards the x the entire problem. Okay? In contrast to this one, where the mouth faced the x and didn't at the end. This is a change in inequality direction. This is not. Okay? All right. We're going to move on to some more advanced inequalities here. Example 5, x plus 7 over 22 is greater than or equal to 5. The LCD is 20, or LCD is 22, so we will multiply both sides by 22. Again, we handle these exactly like equations. So we have x plus 7 is greater than or equal to 110. Subtract your 7, and x is greater than or equal to 103. And I also want to talk about 3-part inequalities. And this is going to be our transition to another form of inequality notation. Sorry, I want this to be 27. Okay, to do this properly, what you're going to need to do is you're going to need to isolate the x. And you do what you need to do to decide with the inequality, the other side, and the other side. So this gives us negative 4 is less than 4x, which is less than or equal to 28. Then we divide off the 4. The x's cancel, and we have negative 1 is less than x, which is less than or equal to 7. All right, so this is where I want to introduce interval notation. Interval notation. We use brackets for the or equal to's. We use square brackets for the or equal to's. We use rounded parentheses for the strict inequality signs. We also use them for any version of infinity. We list it with lower bound, upper bound. So that's the order that is followed. So for this type of problem, we're saying that x is between negative 1 and 7, but it doesn't include negative 1. So negative 1 is the lower limit, 7 is the upper limit. Because it's not all equal to, we use a parenthesis for the negative 1. We use a bracket for the 7 because of the or equal to. All right, example 7. Five minus 2x is less than or equal to 23. So I would subtract the 5. Negative 2x is less than or equal to 18. We're going to divide off the negative 2. And we have x, negative 9. It was divided by a negative, so they now faced away from the x and now face towards the x because we divided by a negative. In interval notation, we have negative 9, and we have x big more. So it's either negative 9 or more. So negative 9 is the lower limit. There is no limit to how big these can get. We'll use a square bracket for the negative 9 because of the or equal to. Infinities always get a rounded parenthesis. Okay, example 8. Seven minus 10x, how about 7 plus 10x, is greater than or equal to 1. Let me make it less than or equal to 1. So I subtract the 7, and 10x is less than or equal to negative 6. Divide off the 10. Now, we got x, we got negative 3/5 when we reduce. We divided by a positive number, so we don't switch the inequality direction. Now, for this type of problem, negative 3/5 is higher, is equal to or more than x. Because it's more than, possibly, it's the upper limit. So since there is no other number, aversion infinity must be used. So since the lower limit is always used as negative infinity if there is no limit, no lower bound. Stated. So bracket because of the or equal to, parenthesis because of the infinity. All right. Example 9. Seven plus 12x is less than 31. So we subtract 7. We have 12x is less than 24. Divide off the 12. We have x, we have 2. We didn't divide by a negative, so the inequality direction doesn't change. Now, x is less than 2, 2 is greater than x. So that makes 2 the upper limit. We put a parenthesis there because it's a strict inequality. There's no lower limit stated, so we use negative infinity. And it always gets around a parenthesis because it's infinity. Example 10. X over 7 plus 1 over 2 equals 3. The LCD is 14. So we have 14 times x over 7 plus 14 times 1/2 equals 14 times 3. Cancel, we have 2x, we get 7, nothing cancels there, so 2x plus 7 equals 42. Subtract your 7. I'm sorry, this is not an inequality. Greater than, greater than, greater than. Okay, now it's an inequality. So let me start all over again. The LCD is still 14. So I will multiply both sides by 14. I didn't multiply by a positive or I didn't multiply by a negative, so the inequality direction doesn't change. 14 divided by 7 is 2. 14 divided by 2 is 7. And that gives me 2x plus 7 times 1 is 7 is greater than 42. Subtract your 7. And 2x is greater than 35. Divide off your 2. Now, I didn't divide by a positive, so x is still greater than 35 halves. Now, this means x is greater than 35 halves, which means that's the lower, that's as low as that's our lower limit. That's our lower limit. There's no limit to how big x can get, so we'll use positive infinity for the upper bound. Parenthesis always goes within infinity, and because of the strict inequality sign, we're going to be using a parenthesis here too. All right. Okay. Okay, now I want to extend this to graphing inequalities. We're going to be using two different notations for these. Traditional uses closed dots for the strict inequality sign, for the or equal to's, and uses open dots for the strict inequalities. Integral notation uses brackets and parentheses. So, example 1. Three minus 6x is less than or equal to 39. Actually, I'm going to make it negative 39. Okay, so I subtract 3. We have negative 6x is less than or equal to negative 42. We divide off the negative 6. We get negative 42 over negative 6. We get x. We get 7. Now, because we divided by a negative, the inequality direction changes. In interval notation, 7 is the lower limit, or 7 is the lower limit because x can get infinitely large. So 7 to infinity. Because x is either 7 or it's more. And it could be infinitely more. Bracket for the 7 because of the inequality, because of the or equal to. Parenthesis always goes with a version of infinity. Now, traditional graphing would look like this. We got a 7, we got 6, we got 8. I basically put the two neighboring numbers there. The numbers that are greater than 7 are over here. And we use a closed dot for the or equal to. That's traditional notation. Interval notation looks like this. Okay? The numbers that are greater than 7 are this way. And because it's or equal to, we're going to enclose it, the shaded region, with a bracket. Like so. Okay? 5 plus 13x is greater than 83. Subtract the 5. We get 13x is greater than 78. Is that visible? Yes, it is. Okay. I should move it over a little bit. Okay. Divide off the 13. Like so. We get x, we get 6. So we divide it by 13, so the inequality direction doesn't change. So 6 is our center point. 7, 5. We shape, so if we're going to do traditional, this time I'll do interval first. X is greater than 6, so we shade the numbers that are greater than 6. In an interval notation, we will enclose that with a rounded parenthesis. Oh, I forgot to write interval notation. First of all, if x is greater than 6, that means 6 is the lower limit, and there's no limit to how large x can get. Okay. So, I've got two graphs here. 5, 6, 7. 5, 6, 7. So, the numbers that are greater than 6 are over here. In interval notation, I will enclose with a rounded parenthesis. In conventional or traditional notation, I'd use a rounded, open dot. Okay. Like so. All right. Example 3. Example 3, we have 5, let's do 15, minus 8x is greater than or equal to 31. So the first thing I would do is subtract off the 15. Negative 8x is greater than or equal to 16. Divide off the negative 8. We get x and we get negative 2. I divided by a negative, so the mouth will now turn to face away from the x. In interval notation, x is less than or equal to negative 2 means that negative 2 is the upper limit. There's no limit to how low x can get, so we'll use infinity. There's got to be a bracket because of the 4 equal to and a parenthesis for the inversion of infinity. Graphing this, negative 2 is in the middle, and the negative number line works in reverse. So negative 3 is less than negative 2, negative 1 is greater than negative 2. Okay, now in interval notation, you've got to be shading the numbers that you're going to be shading the numbers that are less than negative 2. So negative 3, negative 2, negative 3, negative 4, negative 5, and so on. Okay. You're going to enclose it with a square bracket. Now, in traditional notation, you'll shade the same area, but you're going to use closed dots because of the or equal to. Finally, let me show you another one. Okay, example 4 is on the board. What you're going to want to do is add 7 to both sides. We get negative 4 is less than or equal to 6x, which is less than 30. Divide off the 6. And we end up with negative 2/3. And we reduce x and 5. Now, we divide it by a positive number, so the inequality direction doesn't change. So everything stays the same. Graphing this, because there's only 2 numbers, you really only need to plot both of them on the number line. So we got negative 2/3, we got 5, negative 2/3, 5. It doesn't need to be any type of scaling on a sketch. Now, we're going to shade the numbers that are between these two values. In interval notation, you're going to use a bracket. We're going to close this with a bracket for the or equal to's and a parenthesis for the 5. Around a parenthesis for the 5. In traditional notation, that's going to get a closed dot because of the or equal to. That's going to get an open dot because it's a strict inequality sign. Okay.